This video will demonstrate how to remove elements from a doubly linked list. Hello, I'm James Helfrich. When we remove a node from a doubly linked list, we have to be careful to hook the pointers up correctly. First, we have to remove the pointers from the previous node and the next node, and then remove the node itself. This video will demonstrate how this works. Remember, there are two types of linked list. There's a singly linked list and a doubly linked list. The singly linked list can only move forward. A doubly linked list has a pointer to both the next node and the previous node. This video will demonstrate how to remove a node from a doubly linked list. The algorithm is as follows. First of all, if the node we're pointing to that we're trying to remove does not exist, then we do nothing. Next, we modify the previous node and the next node so they no longer refer to the node being removed. The p-remove will no longer be part of the linked list, but p-remove itself will point to the previous and next node. And then the final stage is to delete the node itself. To demonstrate how this works, I'll start with a single node, node 12, and I'll start with a p, which is the null pointer. Now I'm going to insert 85 after p head, which is 12. Then I'll insert 73 after p head, which is 12. And then I'll insert 67, then 52, then 49, then 31, then 28. When I'm finished, I'll have a fairly large linked list. Now I'm going to attempt to remove p head, which is 12, arrow p next, which is 28, arrow p next, which is 31. When I remove 31, the first thing I'm going to do is make sure that 28 no longer points to 31 and 49 no longer points to 31. So now 28 is going to point to 49 and 49 is going to point to 28. Then I'm going to remove 31 itself. And when I'm finished, I'm going to return the pointer to the node after the one I'm removing, which would be 49. Now I'd like to remove p head. To remove p head, first of all, I'm going to make sure 28 no longer points to 12. Then I'll remove p head itself, and I'm going to return the next pointer after, and that will be the new p head. Okay, right now p points to 49. P arrow p next, p next, p next, p next is going to be 85. When I remove 85, then first of all, I'm going to make sure that 73 is no longer points to 85, which will get the null pointer. Then I'll remove 85. Now here's the tricky part. I would normally return p next after the one I'm removing, but since 85 is the tail node, then I'm going to return p head, p previous instead, which should be 73. Now I'm going to move p all the way to 49. And 49 is p arrow p previous, p previous, p previous. And now as long as p is not equal p head, and it's not because p head is 28 and p is 49, then I'm going to attempt to remove p. When I remove p, I'm going to point to the one after it, then I'm going to point to the one after, then I'm going to point to the one after. Now when I remove 73, I'm no longer going to point after, I'm going to point to the one in before. So now p equals p head, so I exit the while loop. Let's take a look at another example. I'm going to start by inserting the values 0, 1, and 2. Notice I use insert without the p after set to true, therefore I'm going to insert before. So this is going to be backwards order, 2, 1, 0, and n is going to point to the first node. Now n arrow p next is node 1. When I remove it, not only will I remove that node, but I will also return the node after, which is node 0. I'm going to ignore the return type. Now n equals remove n. Now since n is pointing to node 2, I'll remove it. And when I finish, I'll point to the node after, and that'll be the new value for n. And when I say n equals remove n, I'm going to remove it. And now n is going to return the null pointer. Let's add a couple more nodes just like before. If I say clear, not only am I going to remove all the nodes, but I'm also going to return the null pointer, or I'm going to change the past pointer to the null pointer. And I can also call clear on the null pointer, and that has no effect. This is the remove section of the linked list chapter of the C++ data structures textbook.